Hello everyone, my name is Ahtesham Shaikh and today I am excited to present a fascinating topic in data structure and algorithms, the Tower of Hanoi. This classic puzzle isn't just a fun problem to solve, it introduces us to essential concepts in recursion and algorithm redesign. Let's get started. Again, let's understand what the Tower of Hanoi puzzle is. It's a well-known problem involving three rods and a set of disks of varying sizes. The objective is straightforward: move all disks from one rod to another while adhering to a specific set of rules. In a brief, here's the problem. First, move all disks from the source rod to the destination rod. Second, but there are a few important restrictions. Only one disk can be moved at a time. These rules add a level of complexity that requires a strategic approach for finding the solution. Now, let's dive into the rules that guide the Tower of Hanoi puzzle. There are three main rules to keep in mind. First, move one disk at a time. Only the top disk of any rod can be moved to another rod. No larger disk on a smaller disk. A larger disk must never sit atop a smaller one, which is the main constant that adds complexity. Third, move disk to an empty rod or on top of a larger disk. A disk can only go to an empty rod or onto a larger disk if there's one on that rod. While these rules may seem simple, they add an interesting layer of challenge to the puzzle. Let's set up the problem step by step. Initially, all disks are stacked on rod A, arranged by size with the smallest disk on top and the largest on the bottom. Rods B and C starts off empty. Here's the objectives. First, move all disks from rod A to rod C. Second, rod A starts fully loaded while rods B and C are empty. Following the rules we just discussed, we need a strategic approach to achieve this goal. Next, we will explore how recursion can help solve this puzzle. The Tower of Hanoi is a great example of using recursion to solve complex problems. The key idea in the recursive solution is that we can break the problems into smaller, similar subproblems. Here's the approach. First, move the top N1 disk from the source rod to the auxiliary rod. Second, move the largest disk N directly from the source rod to the destination rod. Third, finally move the N1 disk from the auxiliary rod to the destination rod. This recursive breakdown allows us to tackle each part of the problem in manageable steps, illustrating the power of recursion. Now let's look at the recursive algorithm in Python to solve the Tower of Hanoi. Base case. For n is equal to 1, we move the disk directly to the destination. Recursive case. For n is greater than 1, we move n1 disk to the auxiliary rod, move the largest disk to the destination rod, move the n1 disk from the auxiliary rod to the destination rod. This approach gradually reduces the problem size, making it solvable step by step. Let's analyze the time complexity of this algorithm. Time complexity. Each recursive calls involves solving two subproblems of size n minus 1. Space complexity. The space complexity is O bracket n as the maximum recursion depth is equal to the number of disks. As you can see, the Tower of Hanoi's time complexity grows exponentially with the number of disks. Tower of Hanoi puzzle is more than a challenge. It has valuable applications. First, recursion. Its prime example for teaching recursion, helping students breaking down problems into smaller subproblems. Second, algorithm design. It demonstrates divide and conquer strategies, breaking down large problems into manageable pieces. Third, data structures. It's commonly used to illustrate stack operations as the disk movement resembles stacking and unstacking of operations. Game theory. The Tower of Hanoi appears in AI and game theory, offering insights into puzzles that require optimal strategies. In conclusion, here are the key points. First, the Tower of Hanoi is a fundamental problem that demonstrates recursion as it breaks down complex problems into simpler steps. Second, the recursive algorithm has a time complexity which grows exponentially. Third, the, the puzzle helps deepen understanding of algorithm design, recursion, and time complexity analysis. Fourth, the Tower of Hanoi is often a stepping stone for learning more advanced algorithmic techniques. Thank you, everyone.